y'all have any homework questions y'all want to go over or anything? Nope. Everybody good? All right, that's either a good sign or a bad sign. That means y'all ain't do nothing or y'all did everything and it's just mad easy. I don't know. All right, we good then. So let's look at what we're getting into today. All right. Again, I'm just kind of catching up with where we left off from last class. I didn't get to finish the whole lesson, so we're gonna finish it now. Then we're gonna go into a new topic for today. All right. Homework's already posted, so if you feel like you know it already, no problem. Just go on and knock it out. All right. Mm-hmm. Oh yeah, you take it. Where? I mean, I already have it plugged in. It's easy if you want. Yeah. Just do one of these. Sorry about that. Well, you're good. You're good. Yeah. All right, so that's what we're doing for today, right? We're going to use scientific notation. So working with very large or very small numbers can be awkward. Since our number system is base 10, we can use powers of 10 to rewrite very large or very small numbers to make them easier to work with. Consider the numbers 4,000 and 0.004, right? Using place value, we can rewrite the numbers 4,000 and 0.004. We know that 4,000 means 4 times 1,000, and 0.004 means 4 times 1 over 1,000. That's 4 thousandths, right? If we write the 1,000 as a power of 10 in exponential form, we can rewrite these numbers in this way. So 4,000 becomes 4 times 1,000. 1,000 can be written as 10 to the third power. So 4 times 10 to the third power. All right. Let me say something about this real quick. All right. Um, just bear with me 1 second. So I'm talking about right here, right? This is 4 times 10 to the third power, right? If you're in web work, right? This is how you type in 4 times 10 to the 10th to the third power. It's going to be 4, the letter X, oh no, space, right? Little space, the letter X, another space, and then you could do the 10. And instead of doing the caret to the third power like that, use the that little button on the right hand side, the one that looks like this. Use that button to raise it to the power and then just write the power up here. Right? So that's how you would write it if you were doing it in WebWork. Any questions on that? So we need spaces. That's the secret. You put a little space, boom, boom, and then it'll work. All right. All right. 0.004. We know that that's going to be 4 times 1 over 1,000, which is just going to be 4 times 1 over 10 to the third power, which becomes 4 times 10 to the negative 3 power. Again, when you're doing this, you need space, right? Like when I say space, I mean like hit the space bar. Put a space in between it, and that's how WebWork will accept it. Okay. All right. Well, a number is written as a product of two numbers where the first factor is a number greater than or equal to 1, but less than 10, and the second factor is a power of 10 written in exponential form. It is said to be in scientific notation. All right. So scientific notation is a number is expressed in scientific notation when it is of the form a times 10 to the nth power, where 1 is less than or equal to the absolute value of a, which is less than 10, and n is an integer. Blah, blah, blah. A, right, is going to be some number that's less than 10, but bigger than 1. That's all that's saying, right? So you can't have, for example, 11.321. That's not scientific notation, right? And you can't have 0.123. That's not scientific notation. Go ahead. Yeah. It could be negative. Yeah. Yeah. It could be negative and the power could be negative also. So when the power is negative, what that means is that the, the A value could be negative. Yeah, yeah. Like it could be negative 1.53. That's fine. Or right, it can't be negative 10. Yeah. Right. Right. hmm Actually, since you mentioned that, right? That's what these double bars right here mean, right? With the absolute value, that it could be positive or negative, right? All right. Do-do-do-do. Oh, I'm about to show y'all the secret sauce right here. Right. Go ahead. Yeah. Your question. Got you, got you. All right, no problem. All right, this hint right here, this is a shout out for you right here. Mhm. All right. So it is customary in scientific notation to use as the X multiplication sign, even though we avoid using the sign elsewhere in algebra. If we look at what happened to the decimal point, we can see a method to easily convert from decimal notation to scientific notation. So I have 4,000, right? So it's 4,000 decimal, right? Like this. It's 4,000 decimal. So there's a decimal right here, right? If I move the decimal, right? One, two, three spaces to the right, right? Then I get the 4.0 that I want times 10 to how many times did I move it? Three, right? So when you move the decimal point three spaces to the left, it becomes positive. And then you have the reverse, right? Let's say I have 0.004. I'm going to move this decimal point right here. One, two, three spaces to the right. And when I move three spaces to the right, this becomes what? 4.0 times 10 to the negative 3. So when you move the decimal point three spaces to the right, it becomes negative. All right? Questions on that? All right. So in both cases, the decimal was moved three places to get the first factor between 1 and 10. The power of 10 is positive when the number is larger than 1. So 4,000 equals 4 times 10 to the third. And the power of 10 is negative when a number is between 0 and 1, which is like 0.04, is going to become 10 times 4 times 10 to the negative 3 power. All right. That little fact could help you out a lot. All right. I know you hear me talking a lot, so let me just give y'all some notes real quick before we try one. All right. So here you go. This is how to convert a decimal to scientific notation. So step one, move the decimal point so that the first factor, the first number, right, is greater than or equal to 1 but less than 10, right? Step two, count the number of decimal places n that the decimal point was moved, right? Step three, write the number as a product with a power of 10. If the original number is greater than 1, the power of 10 will be 10 to the n power, positive exponent. If it's between 0 and 1, the power of 10 will be 10 to the negative n power, right? it should be a negative power. And then step 4, check. Let's try it out. So I'm looking at A. A is 37,000. That's the number. 37,000. Somebody tell me what that is in scientific notation. 3.7 times 10 to the what power? Very good. That's it. Any questions on how we got that? Huh? So there's an imaginary decimal at the end, always, for all the whole numbers. And I just move it over till I get the first digit to be between 1 and 10. So 1, 2, 3. See, I can't stop right here because 37 is not between 1 and 10. So I go one more, 4, right? To the right. So this is 3.7 times 10 to the fourth. All right. How about B? A little bit harder. All right. What is B in scientific notation? Very good. 5.2 times 10. Well, I'm sorry, I didn't get the power. Say it again. Not to the third. Give me a better answer. No, give me a better answer. Hmm. Not 4. Give me a better answer. Go ahead. Negative what? Yeah, -3. That's it. Right? So I have the decimal point right here, right? And I want to move that over 1, 2, 3, 3 spaces to the right. So that's why it's negative, right? Also, the number is 0.0052, is between 1 and 10. So that's just going to be negative. It's another way to think about it. Right? Right. Because I need that first digit to be between 1 and 10. After it's between 1 and 10, I'm Gucci. Yeah. And I can't go further out because 52 is not between 1 and 10. That's too big. So it has to stop right there. Any questions on this? Anybody? All right. Okay. It's always times 10 to some power. Yeah, I don't know what that power is going to be. It depends on how many spaces I'm moving. Right? Just count. That's it. It's by base 10, if that's what you mean. But I just count how many times I'm moving the decimal. And then however many times I'm moving it, that's the exponent power. That's it. On your homework though, if you were to type this in, remember to use that space, right? Space between the first number, then the X, then space between that and the 10 to the power. And that's how WebWork will take it. All right. Do y'all feel good about this or y'all want to try one? All right, I'm gonna take y'all silence like y'all understand. I'm gonna move on. All right. So a little bit different now, but it's the same idea. All right. How to go in reverse. All right. So how can we convert from scientific notation to decimal form? Let's look at two numbers written in scientific notation. So we have 9.12 times 10 to the fourth power. You know that 10 to the fourth power is actually 10,000, right? So we have 9.12 times 10,000. That's going to become 91,200, right? Also, I have 9.12 times 10 to the negative fourth power. Now, we know that 10 to the negative fourth power is 0.0001, right? So 9.12 times 0.0001 is 0.000912, all right? So if we look at the location of the decimal point, we can see an easy method to convert a number from scientific notation to decimal form, right? So look, if I have 9.12 times 10 to the fourth power, right? I could just write down the 9.12 and move the decimal point over four spaces to the right, and that's how I get the number 91,200, right? So let me show you. I'd say I have 9.12, right? It's times 10 to the fourth power. I'm just going to move this over four spaces. 1, 2, 3, 4, right? So that's four spaces to the right. Fill in the zeros. This is 91,200. Just like that. The same thing with the other one, right? I have 9.12, right? Times 10 to the negative 4. So I'm just going to move this over four spaces. 1, 2, 3, and 4, right? So that's four spaces to the left. 0, 0, 0. So this is what? 0.123 zeros and then 912. That's it, right? So in both cases, the decimal point moved four places. When the exponent was positive, the decimal point moved to the right. When the exponent was negative, decimal point moved to the left, right? That's the secret sauce right there. All right, let me get y'all with some notes real quick, and then we'll try one. All right. So this is how to convert scientific notation to decimal form. Step 1, determine the exponent n on the factor 10. Step 2, move the decimal n places, adding zeros if necessary. So whatever the exponent is on the 10, that's how many places you're going to move the decimal. So if the exponent is 3, you're going to move the decimal 3 spaces, right? That's simple. If the exponent is positive, you move the decimal point n places to the right. If the exponent is negative, you move the decimal point n places to the left. And then step 3, check your answer. Let's try it out. Let's try it out. Check this out. I got 6.2 times 10 to the third power, right? All right, that's 6.2 times 10 to the third power. Tell me how to do this. What am I going to do? I have the 6.2 right here. Tell me what to do. What? Yeah, go ahead.
Six hyphen two decimal place
Mhm.
three spaces this way.
Good.
Writing it six hyphen two zero.
Perfect, right? So I just move the decimal place three spaces to the right. Why 3? Because the power is 3. Bless you. So my answer is 6,200, right? Let's look at B. So for B, I have negative 8.9 times 10 to the negative 2 power. So starting off with the negative 8.9, tell me what to do. Where am I going to move the decimal? To the left or the right? Two spaces. Perfect, right? So 1 and then 2. Exactly, right? So just because I have the magic of the computer, I can do that, right? So what's my answer? It's negative 0.089. And that's it. All right. Mhm. Mhm. I got you. For which one?
Oh, my 0.89. So you added the extra zero.
Yeah, because I have to go two spaces to the left. So the first space is in front of the 8, and then the other space is in an extra 0.
So use that logic. The other one that's up, it's supposed to.
Which one?
The 62,000. The 6,000.
Yeah, it got two extra zeros actually, because it was going on three spaces. Yeah. I like to put those little arrows to show in which direction I'm moving the decimal. You That's my suggestion to you guys. That'll make it a little bit easier. Mhm. Want to do another one? All right, go ahead. To the right, yeah. It's bigger. Yeah. All right, we're gonna try another one. Yeah, exactly. All right, you guys try it real quick. Oh, sorry about that. I messed it up. All right, go ahead. All right, let's do this real quick. What's the answer for A? Very good. 1,300. Any questions on A from anybody? All right, what's the answer for B? So 0.0012. Uh, two. One more zero because it's four, right?
So it's not gonna count the one.
The one is counted, right? But it's four spaces. So if you count the one, you only move three spaces. So look, I have 1.2 like this, right? And I'm gonna move this over four spaces. So one, two, three, four, right? Going this way. And each one of those loops gets a zero, right? So the answer is negative 0.123 zeros and then 1, 2, like that. So that's how we do it. Yeah. Questions on it, anybody? All right, new idea. I promise you're gonna love this one.
It's kind of count the one.
Yeah. Yeah, you go to the left like that, yeah. All right. So when scientists perform calculations with very large or very small numbers, they use scientific notation. Scientific notation provides a way for the calculations to be done without writing a lot of zeros. We will see how the properties of exponents are used to multiply and divide numbers in scientific notation. So check this out. All right. I'm looking at A. So A is -4 times 10 to the fifth power, right? Times 2 times 10 to the -7, right? So all you got to do, right? Numbers with numbers, exponents with exponents, right? Y'all got to help me out though, because y'all know my timetables are not too great. What's -4 times 2? -8, right? Very good, right? And then now we're going to multiply that times 10 raised to what power? I have 10 to the fifth times 10 to the -7. That's going to become 10 to the, what operation do I use? Addition, right? This is going to be 5 plus -7, which is what? -2, right? So that's my final answer. -8 times 10 to the -2 power. And that's it. Questions on this? All right, so we combining our rules of exponents with this. All right. Let's try B. Oh, this is gonna be fun. B. All right. Very, very, very easy. I have 9 times 10 to the third power divided by, let me scroll down a little bit. Let me scroll down a little bit. 3 times 10 to the -2 power. Right? Remember, numbers with numbers, exponents with exponents. So what's 9 divided by 3? Go ahead. 3, right? So this is 3 times 10. Now, when I divide exponents, what operation do I use on the power? Subtraction, right? So remember, it's always top minus the bottom, right? So that's 3 minus -2, which becomes what? This was 3 times 10 to the what power? Fifth power. Excellent. And that's it. That's my answer. All right. Any questions on this? Anybody? Yeah, I'll be there. It's also on the review sheet. You can check it out. Yeah. So we good? Yeah, I have them in their homework, so you'll be able to practice some more. All right, so that's it from last class. Let's start our new topic for today. Y'all gonna have to help me out with this one, man. This multiplication. Y'all know I don't know all my timetables, so y'all gonna have to help me out. All right. But before we get into it, we're gonna start with a little blast from the past. How I do this? This thing said distribute. What that mean? Very good, right? So I'm gonna do one of these, right? So tell me what the answer is. 2x plus 6. Excellent. That's my answer. Any questions on how I do this? Anybody? You just distribute. That's it, right? Little arrow means multiplication. Oh, baby. This one's for Sasha right here. Coming up. Yeah. So watch what we got now. We got a 9 squared. All right. Where my blue pen at? There we go. So for A, right, I got 9 squared. What's 9 squared again? 18? That's good. Give me a better answer. 81, right? So remember, 9 squared means 9 times 9, which becomes 81, right? All right. How about B? Now for B, I got negative 9 squared, which is what? Give me a better answer. Mhm. It's all right. Teaching one, right? 81, right? So remember, in parentheses, the negative 9 squared means what? It means negative 9 times negative 9, which is positive 81. Because a negative times a negative is a positive, all that good stuff, right? All right. Let's get this. Where's the purple at? Let me get the purple, right? So I got C. So what is negative 9 squared? What's the answer for that? Negative 81, right? Because this is negative 1 times 9, which is negative 81. Awesome. Any questions on these three? Anybody? This makes sense? All right. And y'all already know y'all favorite examples coming up next. Wouldn't be a real class if we didn't do one of these. All right. So I want to evaluate. I have 2x squared minus 5x plus 3 when x is equal to negative 2. Tell me what to do. How do I do this? Very good. All right. Can you help me out with it though? What's negative 2 squared? Hmm?
Um, negative.
Good, good. Minus 5, minus 2, plus 3. All right. So what's 2 times 4? 8. Very good. What's negative 5 times negative 2? Plus 3. Very good. Very good. It's the hard part right here. What's 8 plus 10? 18. All right. And what's 18 plus 3? The legal drinking age, allegedly. Allegedly. At least in America. I don't know about other places. Right? So there's no age, right? Nice. Right? I heard years ago they used to give like vodka to kids because that makes them sleep better, something like that. Yeah, I could tell you with me when I take like a little shot of wine, and I mean a shot, not an actual glass, like I'd be out. Good sleep too. I might do that tonight. Shoot, get some good Z's. That's what I need. All right. So this our topic for today, right? We're gonna start off with multiplying monomials. Right? So we are ready to perform operations on polynomials since monomials are algebraic expressions. We can use the properties of exponents to multiply monomials. All right. I'm gonna give it to y'all real simple. All right. Numbers with numbers, variables with variables. Period. That's how you do it. All right. Let's try out A. A is 3x squared times negative 4x cubed, right? What was the answer you got? Very good, right? Numbers with numbers, variables with variables, right? We got the negative 12 from the 3 times negative 4. And we got the x to the fifth power because we're doing x to the second times x to the third. And remember, whenever we multiply exponents, we add their powers. right? Questions on this, anybody? It's good. Awesome. All right. Now B's a little bit harder, but don't be scared. It's the same thing, right? So this is what? 5 over 6 x to the third times y times 12 x y squared. What's the answer? Go ahead. Very good, right? So we did 5 over 6 times 12, right? So remember how I multiply fractions, right? I'm going to have the 5 over 6 times, but the 12 is a whole number, right? So we put that over 1. And then how do we multiply? We multiply straight across, right? So this becomes what? 5 times 12 over 6 times 1. Now, y'all know I don't know my timetable, so I got to do something tricky here, right? We know that 6 goes into 6 once and 6 goes into 12 two times. So what does this become? 5 times 2, right? I could put it over 1, but y'all get the idea, right? And 5 times 2 is 10. That's how I get the 10. As for the exponents, you have x to the third times x, right? Remember that this is like x to the 1 power. So 3 plus 1, x to the fourth. Then we have y times y to the second. Remember, this is like y to the 1 power. So y times y to the second, y to the third. And that's how we got this answer here. Any questions on this? Good. All right. Y'all comfortable or y'all need to see another one? Another one? All right. All right, here you go. Let me try that out. What the homework?
Some problem when you did, one of I got myself and then I got the wrong numbers.
Okay.
So
Mm-hmm. What you got?
it's about the operation and you did earlier. For the one, like I in the minus two. So at the beginning, when I did this multiplication, I didn't read out the minus. It was terrible. Yeah, so that's what I just figured, and I keep going into the same one. So. So it was ever assigned tree limit. Okay, so basically, separate.
All right, we got the answer for this. What's the answer for A? But you could do it in your head.
No,
Remember, numbers with numbers, variables with variables. So what's 5 times -7?
negative 3.
Very good. And then what's y to the 7 times y to the 4? It becomes y to the, what is it? Very good. And that's it. All right. Questions on that? Remember, we just add the exponents. That's it. How about B? What we got for B? What's 2/5 times 15? Very good. 6. A to the 5th. Very good. Perfect. Well done. That's my answer. Questions, anybody? All right. No, no, multiply. Multiply. Yeah, so 2/5 times 15, right? The 5 goes into 15 three times, and 2 times 3 is 6. Think of it like that. So yeah, a little bit of a division. Yeah. And then a multiplication. If anything, use your calculator. Just type it in, click enter. Yeah. All right. New topic. All right, it's the same topic, but with a variation. So we're going to multiply a polynomial by a monomial. All right. So multiplying a polynomial by a monomial is really just applying the distributive property. That's all we're doing. Just distribute. Right. Let's look at A, for example. Right. I have negative 2y times 4y squared plus 3y minus 5. Right. All you're gonna do, right, is distribute. You're gonna take that negative 2y, just gonna multiply it times every single term. And that's the end of the problem. Let's try it out. Let's try it out. Right? So negative 2y times 4y squared, negative 2 times 4, I think that's like what, 8 maybe? A negative 8. And then y times y squared, that's like what? Y to the third power, something like that, right? Then we take the negative 2y times the positive 3y. So negative 2 times positive 3, that's going to give me a negative 6. Y times y is going to give me a y to the second power, because remember that each one of these are to the first. And then last but not least, we have negative 2y times negative 5. A negative times a negative is a positive. 2 times 5 is 10, and we have the y. This is my final answer. Any questions on this? Again, numbers with numbers, variables with variables. All right. When you multiply the variables, you just add the exponents, right? And then you just multiply the numbers as you would anything. Any questions? All right. If you feel like you understand everything after this example, you could just pretty much start your homework, because this is all your homework is. Distribute, combine like terms. That's your whole homework. All right. I'm gonna start off with another one. I have 3x to the third y times x squared minus 8xy plus y squared, right? This is the same game. It might look different, but it's the same thing, right? Just distribute it. Take the whole thing. Multiply it times the first term. Tell me what I'm going to get. Perfect. All right, next term, what am I going to get? Perfect. Perfect. All right, last term. What am I going to get? Perfect. This is my final answer. Right? Let's distribute that onto every single term. Remember, numbers with numbers, variables with variables, right? X's go together, Y's go together. That's it. Questions on this, anybody? All right. That's your whole homework right there. Everything else I got for the rest of the day is just variations on this one idea. So here's another variation on it. I feel like after you see this, you're gonna be good. You're gonna be like, oh, okay, I get it. You know? So this is multiplying a binomial by a binomial. This sounds mad funny, right? But all of y'all know how to do this from high school. Watch when you see what it looks like, right? So just like there are different ways to represent multiplication by numbers, there are several methods that can be used to multiply a binomial times a binomial. We'll start by using the distributive property. Oh, baby. Wait till you see this. Wait till you see this. It's a true blast from the past. I know everybody here seen this before. Here it comes. Bam. You got the binomial times a binomial, right? Let's look at A real quick. So I got what? Y plus 5 times Y plus 8. Tell me what to do.
Y squared plus 8y plus 5y plus. um,
Very good. And then you combine like terms, right? It was 8 plus 5. Very good. So y squared plus 13y plus 40. Right? Here's how we do that. You guys remember the FOIL method, right? First, outer, inner, and last, right? Just distribute, combine like terms. That's how we do that. Questions on that? You good? All right, let's try the next one. Yeah.
Plus,
Let's see. Let's try the next one. So I got 4y plus 3 times 2y minus 5. All right. It might look different, but it's the same thing. Distribute first. All right. So what do you have? Perfect. Minus 20y. Very good.
6y.
Plus 6y. And then minus 15. Perfect. And then now we want to combine like terms. So what is a negative 20 plus 6? Very good. Negative 14y minus 15. This is my final answer. Any questions on this? I forgot the arrow. Hold on, I forgot the arrow. There we go. Any questions on this? You good? All right, true blast from the past. True blast from the past. All right, let's move on. All right. So if you multiply binomials often enough, you may notice a pattern, right? Notice that the first term in the result is the product of the first terms in each binomial, and the second and the third terms are the product of multiplying the two outer terms and then the two inner terms. And the last term results from multiplying the last two terms, right? So this is just answering, setting up, excuse me, our FOIL method. So that we're coming to that. Yeah. That's called a perfect square trinomial. Yeah. But I'm happy you know that though. All right. So we abbreviate, right? First, outer, inner, last as FOIL, FOIL. The letters stand for first, outer, inner, last. We use this as another method of multiplying binomials. The word FOIL is easy to remember and ensures that we find all four products. So, for example, let's say we're multiplying x plus 3 times x plus 7. In the distributive property, you break up the first term, so it'll be x times the x plus 7 and 3 times the x plus 7. Distribute both, combine like terms, boom, you get the answer. In the FOIL method, you multiply the first times the first, and then the first times the outer, then the second times the first, and then the second times the second in the end. Boom. And then to summarize the steps of the FOIL method only applies to multiplying binomials, not other polynomials. So basically, what does that mean? The FOIL method is a trick that only works when you're multiplying two binomials. But when you have to multiply two polynomials, you want to use a distributive property. That'll be the easier one. All right. So check this out. How to use the FOIL method. So use the FOIL method to multiply two binomials. Step 1, multiply the first terms. Step 2, multiply the outer terms. Step 3, multiply the inner terms. Step 4, multiply the last terms. And then step 5, combine like terms when possible. And that's it. All right. Those of you that want to take notes, go ahead. What's your
Square two. Got column. That.
right? That will work for all polynomials. Yeah, yeah, yeah.
If you have to specifically find.
Then you have the option to use FOIL, or you could just use a distributive property, right? If it was me, right, I would rather you have one method that works for all questions that you memorize, aka the distributive property, right? Then you coming in with 2, 3, 4 methods, all right? But yeah, which one? Distributive. I agree. I think that one is the most useful. But like I said, on test day, I want you to have one strong one. I don't need you having 5, 6 different methods, right? When you guys are in your careers and you're on your lunch break, you can learn the other method. All right. All right, since we did FOIL last time, let's do the distributive with this one. So when you multiply by 4 method, drawing the lines will help your brain to focus on the pattern and make it easier to apply. Now we'll do an example using the FOIL. I'm actually going to change this up. We're going to do an example using the distributive. All right. So check this out. For A, I know we all know how to do this. Just humor me for a second, right? This is y minus 7 times y plus 4, right? I'm going to break up the first binomial. So this is going to become what? Y times the second term, the whole second term, y plus 4 times the minus 7 times again the y plus 4. All you have to do after you get it like this is just distribute this. Bam, bam. Right? Same thing. Bam, bam. Right? What do I get? Y times y, y squared. Y times 4 plus 4y. Negative 7 times y, negative 7y. Negative 7 times 4, that's like what? Negative 28. After that, combine like terms. Remember, that's a fancy way of saying add, right? So 4 plus negative 7, this is going to give me a y squared minus, what's this? 3y minus 28. That's it. That's a distributive property, right? Let's try it again. A little bit harder, but not impossible, right? I have 4x plus 3, parentheses, times 2x minus 5, right? We're going to break up the first binomials. This is going to become what? 4x times the whole second term, 2x minus 5. And then we're going to write the plus 3 times the same thing, the 2x minus 5. Distribute. So 4x times 2x is going to give me 8x squared. 4x times negative 5 is a negative 20x. Then we're going to distribute this. This is going to be 3 times 2 plus 6x. And then 3 times negative 5, negative 15. Adding these together, I'm going to get what? 8x squared minus 14x minus 15. And there you go. That's my answer. Questions on this method? Anybody? This is a distributive method that works for all polynomials. If it was me, I would learn this method and walk into the test and be able to answer all the questions. Just break up the first polynomial, distribute, you're done. Good. It's already available. You can look it up right now. Like the homework, you mean? Oh, YouTube? Maybe like tomorrow, because I need time to download it. That's why. Yeah. But you know how to search, you could probably find a video online already from like a previous class. All right. New question. Y'all already heard the trick, so if y'all want to knock out y'all homework, go ahead. So the final product in the last example were trinomials because we could combine the two middle terms. This is not always the case. So check this out, right? I'm going to have two binomials multiplying together, but I won't be able to combine like terms. So that means that my answer is going to have 4 terms, and that's it. So let's try it out. So I have A, right? This is n squared plus 4 times n minus 1, right? Let's say I break this up. This would be n squared times n minus 1 plus 4 times n minus 1. Distribute, bam, bam. N squared times n, this is n to the third power. N squared minus 1, this is minus n squared. And then distribute this, so 4 times n, this is going to be plus 4n. And then 4 times negative 1, this is negative 4. This is my final answer. Nothing can be combined. They're all different terms. And it's right. Questions on this? Anybody? All right, let's try another one. I have 3PQ plus 5 times 6PQ minus 11, right? We want to distribute, right? So 3PQ, oh no, let me not even do it like that. Let me go back. I'm sorry. 3PQ, force a habit. This is going to be times 6pq minus 11 plus 5 times 6pq minus 11. All right, 3pq times 6pq is what?
P squared Q.
Perfect. P squared q squared. And then 3pq times 11 is what? Times negative 11, excuse me. 3pq times negative 11, what's that? All right, 3 times negative 11, this is negative 33pq. Then we have positive 5 times 6, this is plus 30pq, right? And then positive 5 times negative 11, this is negative 55, right? I have negative 33pq, positive 30pq, combined like terms. I get 18 p squared q squared minus 3pq minus 55. And that's it. Any questions from anybody? All right. Just got more of the same. Do I even want to do this? All right, check this out. If you guys have your method that you're comfortable with and you're getting the right answer, use that method. But I'm gonna show y'all another method just to get it on video. You can practice it if you want to learn a new method, but I recommend you just going into the test with one strong method that works for all questions. But check this out, right? So the FOIL method is usually the quickest method for multiplying two binomials, but it only works for binomials. You can use the distributive property to find the product of any two polynomials. Another method that works for all polynomials is the vertical method. All right, new method called vertical method. So it is very much like the method you use to multiply whole numbers. Look carefully at this example, right, for multiplying two-digit numbers. So say I had the number 46 times 23, right? We all know how we would do this, right? This would become 6 times 3 is 18. So we write down the 8, 1 up here. 6 times 2 is 12, plus 1, 13. So 138. Imaginary 0. Then you do 4 times 3 is 12, 2, 1 up. 4 times 2, 8, plus 1, 9, right? And then you want to add these together and you get 1,085, right? Partial product plus partial product equals the product, right? We all know how to do that, right? What I'm trying to tell you is that this same method can be applied to multiplying two polynomials, right? Check this out. Just humor me for a second. I know you know how to do this. This is 3y minus 1 times, I shouldn't have done that. Let me do the dot, times 2y minus 6. It's the same thing, right? We're going to start off with the negative 6. Negative 6 times negative 1 is what? Positive 6, right? Now, negative 6 times 3y is what? Negative 6 times positive 3y is what? Go ahead.
Uh,
Negative 18y, right? Now, imagine I'm going to do like imaginary 0 here. 2y times negative 1 is what? negative 2y, right? And then 2y times 3y is what? Okay, 6y, what? Very good, squared, right? And then we're going to add these up. 6 plus 0 is what? Good. Negative 18y plus negative 2y is what? Negative 20y. And then we just bring down the 6y squared. This is my answer. This is the same vertical method that you guys know from regular numbers. You can do this as well. This will work for all polynomials in addition to the distributive method. Again, pick one, focus on one, and that's it, right? Use your homework to practice it. Questions on this? Good. I know somebody is just thinking right now, what was all the methods again? Let me see them written out real quick. Got you. All right. So we have now used three methods for multiplying binomials. Be sure to practice each method. Practice one, right? And try to decide which one you prefer. The methods are listed here all together to help you remember. So multiplying two binomials. To multiply binomials, you use either the distributive property, the FOIL method, or the vertical method. Your choice. I don't care what you use as long as you give me the right answer. All right. All right, check this out. So now we're at the stage where we're multiplying a polynomial by a polynomial. So we have multiplied monomials by monomials, monomials by polynomials, and binomials by binomials. Now we're ready to multiply a polynomial by a polynomial. Excuse me. Remember that FOIL will not work in this case, but we can use either the distributive property or the vertical method. All right, let's try it out. So I want to multiply b plus 3 times 2b squared minus 5b plus 8. I'm going to do it twice, one by the distributive property, one by the vertical method. I don't care which one you use. Just give me the right answer. All right, distributive property. Let's look at A. All right? You're going to break up the binomial. So this is going to become what? B times 2b squared minus 5b plus 8 plus 3 times 2b squared minus 5b plus 8. All you're going to do is distribute and then combine like terms. So I'm going to distribute this b onto all three terms here, right? So b times 2b, this becomes 2b cubed. B times negative 5b is going to give you negative 5b squared. Very good. And then b times 8, this is just going to be 8b. Last but not least, we have the 3. 3 times 2b, this is going to be plus 6b squared. 3 times negative 5b, this is going to be negative 15b. And then 3 times 8, what's that? 16, 24 plus 24. Then after that, you want to combine like terms. Remember, that's a fancy way of saying add. So this is going to be what? 2b to the third power plus b squared, because negative 5b squared plus 6b squared. And then minus, what's that going to be? Negative 7b, right? And then last but not least, plus 24. That's my final answer. That's using the distributive property. Any questions on this? Anybody? All right, let's look at the vertical method real quick. Same question, right? So I have 2b squared minus 5b plus 8. And I want to multiply that by b plus 3. Let me just verify. All right, I'm good. All right, vertical method. That doesn't look good. Let me try that over. Okay. Start off with a 3. 3 times 8 is what? 24. And then 3 times negative 5b is what? Negative 15b. Very good. And then 3 times 2b squared is going to be 6. Perfect. Imaginary 0. Now b times 8 is what? 8b, right? So this is plus 8b. B times negative 5b is what? Very good. B times 2b squared is what? So 2b cubed, right? And then we want to add all of this together. This is going to be what? 2b cubed. I shouldn't have added there. I always add at the end. 24 plus 0 is 24. Negative 15b plus 8b is what? So negative 15 plus 8, what's that? Negative 7b. And then 6b squared plus negative 5b squared is b squared, right? So plus b squared. And then 2b cubed. And that's it. That's your answer. All right? Let's see. Are they the same? Yep. Exact same. Go ahead.
It goes down to further.
Yeah, just b squared. That's it. But 6 minus 5 is 1. Yeah. So that's the vertical method. I don't care what you use. Pick one, fall in love with it, bring it to the test. All right. Questions on this? Any one of these? Good. All right. Like I said, that's your homework for tonight. So just practice, practice, practice. Mhm. All right. So we now have seen two methods that you can use to multiply a polynomial by a polynomial. After you practice each method, you'll probably find you prefer one way over the other. We list both methods are listed here for easy reference. So multiplying a polynomial by a polynomial, to multiply a trinomial by a binomial, use the distributive property or the vertical method. Your choice. Okay? No pressure, your choice. So next, you want to talk about multiply special products. So mathematicians like to look for patterns that will make the work easier. A good example of this is squaring a binomial. When you can always get the product by writing the binomial twice and multiplying them, there is less work to do if you learn to use the pattern. So let's start by looking at three examples and look for a pattern. So look at these results. So we have x plus 9 squared. So x plus 9 squared means x plus 9 times x plus 9, right? However you want to do it, vertical method, distribute, whatever, right? You're going to come out to be x squared plus 9x plus 9x plus 81, which becomes x squared plus 18x plus 81. If I have y minus 7, again, that's y minus 7 times y minus 7. However you want to do it, distributive, vertical method, you're going to come out with y squared minus 14y plus 49. And if I have 2x plus 3 squared, right? That's going to be what? 2x plus 3 times 2x plus 3, which comes out to 4x squared plus 6x plus 6x plus 9. Combined like terms, we get 4x squared plus 12x plus 9. Questions on this? Y'all know how to do it already? This is just a trick that I'm showing you guys. Just you remember your distributive or your vertical property, and you don't even have to memorize this. All right? So what about the number of terms? In each example, we squared a binomial and the result was a trinomial, right? So the trick is if you have a plus b squared, let's look at what that becomes. So now look at the first term in each result. Where did it come from? The first term is the product of the first term of each binomial. Since the binomials are identical, it is just the square of the first term, which is a squared, right? To get the first term of the product, you square the first term. Where did the last term come from? So look at the examples and you find the pattern. The last term is the product of the last two terms, which is the square of the last term. So x plus b squared is just a squared plus something plus b squared. All right. Finally, look at the middle term. Notice that it came from adding the outer and the inner terms, which are both the same. So the middle term is double the product of the two terms of the binomial. So plus 2ab, or if you have a minus b, it becomes negative 2ab, right? To get the middle term of the product, multiply the terms and double their product. Let's put it all together. This is what we have. So this is called the binomial squares pattern. So if a and b are real numbers, a plus b squared is equal to a squared plus 2ab plus b squared, right? So when you multiply them out, this becomes what? A squared plus 2ab plus b squared. With a minus b squared equals a squared minus 2ab plus b squared. So it becomes a squared minus 2ab plus b squared. That's your binomial square pattern. To square a binomial, you square the first term, square the last term, and then double their product. That's all you gotta do. Questions on this? Again, you don't need to memorize this. You have your distributive and your vertical property. It will not fail you. You can use it again and again and again. Don't memorize it. Just use what you know. You know the binomial distribution, you know you know the distribution method and you know the vertical method. Just use that. Don't be confused. All right. This is just a shortcut, a little trick, and it only works on these types of questions. All right? So try these out real quick. So your battery's on? Oh no. Got you guys going. If you want, there's outlets. If you have anything to show.
The beast.
It's charged or it died? Okay.
Just on my iPad. You see, oh.
Got you. All right. For A, just showing y'all the trick, but again, use your distributive property, your vertical, all right? So look, we have what? X plus 5 squared. That literally means x plus 5 times x plus 5, right? Using the shortcut, a plus b squared. This is equal to what? A squared plus 2ab plus b squared, right? So what would this answer be, right? It's going to be x squared plus 2 times what's a? X, what's b? 5 plus b squared. Putting it all together, this becomes what? X squared plus 10x plus 25. That's how you use a shortcut, all right? Again, we got a really short class. We don't got time to be memorizing shortcuts. I'm just showing you this. You have the video. In the future, if you ever need to refer back to it, just refer back to it. But that's the shortcut. All right. Let's look at B real quick. This is what? 2x minus 3y squared, right? Again, I'm using the shortcut, right? This is going to be what? 2x squared minus 2 times a, which is what? 2x times b, which is 3y, plus our b term, which is 3y squared. My fault, I forgot to write the formula. It's like this. It's actually a minus b squared is equal to a squared minus 2ab plus b squared. My fault, I forgot to write the formula first. Anyway, finishing this up, 2x squared, this is what? 4x squared. Negative 2 times 2x is negative 4x. Negative 4x times 3y, that's going to be what? Negative 12xy plus 9y squared. That's my final answer. Again, short class. You don't have time to memorize these, right? Use your vertical method or use your distributive method to answer this. All right. Just know that when it says 2x minus 3y, what does that mean? It means this. It means 2x minus 3y times 2x minus 3y. Right? That's what it means. Do your vertical method or do your distributive method, and you come out with the same answer. You don't have to memorize a shortcut. All right. Questions on it? All right, let's keep it going. All right, this next one is a biggie. This next one is a biggie. So we just saw a pattern for squaring binomials that we can use to make multiplying some binomials easier. Similarly, there's a pattern for another product of binomials, but before we get to it, we need to introduce some vocabulary. A pair of binomials that each have the same first term and the same last term, but one is a sum and one is a difference, is called a conjugate pair, right? Conjugate pair. So, and it is of the form a minus b and a plus b. So check this out, check this out, check this out, check this out. Conjugate pair. So a conjugate pair is a binomial of the form a minus b and a plus b, right? One is a minus, one is a plus. The pair of binomials each have the same first term and the same last term, but one binomial is a sum and the other is a difference. All right. Conjugate pair, conjugate pair. All right. Let's talk some more about that. All right, check this out. All right. So there is a nice pattern for finding the product of conjugates. We could, of course, simply FOIL to get the product, but using the pattern makes the work easier. So let's look at the pattern by using FOIL to multiply some conjugate pairs. Say I have x plus 9 times x minus 9, right? You distribute it, you're going to get x squared minus 9x plus 9x minus 81. Combining like terms, the two middle terms will cancel out, leaving back just x squared minus 81. Let's say I have y minus 8 times y plus 8, right? We're going to distribute y times y squared. This y times 8 is plus 8y. Negative 8 times y is negative 8y. Then negative 8 times positive 8 is negative 81. Combining like terms, the two middle terms will cancel out. I'm left with y squared minus 64. Let's say I have 2x minus 5 times 2x plus 5, right? 2x times 2x is 4x squared. 2x times positive 5x is positive 10x. Negative 5 times 2x is negative 10x. Negative 5 times positive 5, negative 25. Combining like terms, the two middle terms will cancel out. I'm left with 4x squared minus 25. All right. This is the product of conjugates. So what did you observe from the products, right? Or about the products? The product of two binomials is also a binomial when the two pairs are conjugates. Most of the products resulting from FOIL have been trinomials. Each first term is the product of the first term of the binomials, and since they are identical, it is the square of the first term, right? So a plus b times a minus b equals a squared minus basically b squared, right? To get the first term, square the first term. The last term came from multiplying the last terms. The square of the last term was a plus b times a minus b equals a squared minus b squared. To get the last term, square the last term, right? Why is there no middle term? Since the two middle terms you get from FOIL combine to zero in every case, the result of one addition and one subtraction, the product of conjugates is always of the form a squared minus b squared. And this is called the difference of squares, which is going to lead us to a pattern. All right. Called, I'll tell you in a minute. I'm going to tell y'all in a minute. This is a biggie. This is a biggie. the product of conjugate patterns, right? So if A and B are real numbers, then A minus B times A plus B is going to be equal to A squared minus B squared, right? A minus B times A plus B is going to be equal to A squared difference minus, and then B squared is squares, right? So this is the difference of squares. That's what this is called, right? To multiply conjugates, square the first term, square the last term, write it as the difference of squares. Difference means minus, by the way. Just means minus. All right. Good stuff, good stuff, good stuff. All right, let's try this one out. I'm gonna give y'all like 2 seconds to try this while I look up something. By the way, I know y'all just took in a lot just now. If you feeling confused, just remember that I only want y'all to remember one thing from the lesson, either the distributive property or the vertical method. You don't have to memorize all these tricks. Yes, I memorized all these tricks. You don't have to memorize it. One method for all questions. That's it. All right. But real quick, our formula for this is what? No, that was right. A minus B times A plus B is equal to A squared, whoops, minus B squared, right? That's our conjugate pair, right? So for my question here, I have what? 2x plus 5 times 2x minus 5. I'm just using the trick. Again, you don't gotta memorize the trick. You got just want you to use one method. Anyway, this is gonna be what? 2x squared minus the b term, which is 5 squared. A little bit of math. This is what? 4x squared minus 25. That's my answer. All right. Questions on this? Good. All right, let's look at B real quick. You do not have to go as fast as me. Take your time. All right. Even I'm up here making mistakes going too fast. All right. Take your time when you're doing these. All right. The formula is right up top there, right? A minus B times A plus B becomes A squared minus B squared. So what's my answer for this? This is going to be what? 5M, minus, open parentheses, 9N squared, right? Doing the math on this, what do I get? 25. M squared minus 81, as you said, N squared. That's it. I'm done. All right. If it don't make sense, use a distributive property, use a vertical rule. You'll be good. Promise. All right. All right, real quick, because I see the time real quick and I don't want to keep y'all too late. So we just developed special product patterns for binomial squares and for product of conjugates. The products look similar, so it is important to recognize when it is appropriate to use each of these patterns and to notice how they differ. Look at the two patterns together and notice the similarities and the differences. Okay, let's take a look. Mhm. All right, so check this out. At the bottom right there, that'll be our last example, right? So comparing the special product patterns, right? So we have our binomial squares pattern, right? So you have the a plus b squared is equal to a squared plus 2ab plus b squared. A minus b squared is going to be equal to a squared minus 2ab plus b squared. This is squaring a binomial. The product is a trinomial, three terms, right? The inner and the outer terms with FOIL are the same. The middle term is double the product of the terms, right? For the product of conjugates, right? One is a minus, one is a plus. You have a minus b times a plus b. It becomes what? A squared minus b squared. Multiplying the conjugates, the product is a binomial. The inner and outer terms with the FOIL are opposites. There is no middle term. That's the difference between them. All right. This is more for the video. Y'all should just use one method and just get through all y'all questions. But real quick, last example. It says choose the appropriate pattern and use it to find the product, right? I'm just going to fly through this real quick, real quick, real quick. For A, I have 2x minus 3 times 2x plus 3. I notice that one is a minus, one is a plus. This is a conjugate pair. So you already know the answer is a squared minus b squared. So this is going to be what? 2x squared minus the 3 squared. A little bit of math on that. This is what? 4x squared minus 9. I'm done. All right. Let's look at B. I have 8x minus 5, right? Squared, excuse me. You already know, right? So this is going to be what? This is the a minus b squared, which is equal to a squared minus 2ab plus b squared, right? So this is what? 8x squared minus 2 times 8x times 5, right? Plus 5 squared. Whoops. So 8x squared, this is going to give me 64x squared, right? Minus, oh boy, here we go. 25, 30, 35, 40. 40 times 2, this is going to be like 80x plus 25. This is my final answer, right? Again, I'm using a shortcut. You don't need to use a shortcut. Don't memorize it. Vertical method, distributive method. Either one will work for you. All right? Let's look at C. Oh, baby. 6m plus 7 squared. Literally the same question we just did, except, right? This is a sum, right? So you already know what happens with the sums, right? This is going to be a plus b squared. So this is a squared plus 2ab plus b squared. What's this going to be? 6m squared plus 2 times 6m times 7 plus 7 squared. A little bit of math. What is this? 36m squared plus, I'm not even going to hold you. I'm not sure. 6 is, what's that? 21, 42, 84, something like that. Yeah, something like that. M and then plus 49. There we go. That's my answer. Not too bad, right? Again, Use your own method that you're more comfortable with. All right. As my favorite rabbit always used to say, tricks are for kids. Mhm. So we have what? 5x minus 6 times 6x plus 5. They have different numbers, so I can't even use this one. Oh crap. Now I'm out of tricks. Now I gotta go back and use my other method, right? All right, we got 3 minutes. Pick one. Vertical or distributive? All right, how many for vertical? Raise your hand. How many for distributive? I got one hand for distributive. All right, so we're gonna use distributive, right? Break up the first term, right? So this becomes 5x times the 6x plus 5. Then we have the minus 6, and then we're gonna have the 6x plus 5 again. All you have to do is distribute, right? So 5x times 6x, that's gonna give me a 30x squared. 5x times 5 plus 25x. Take the whole thing, negative 6 times 6x, and then times 5. So this is going to give me a negative 36x. Negative 6 times 5, negative 30. Here's the hard part. Combine like terms. It's a fancy way of saying add, right? So this is going to be what? 30x squared. Oh boy, how we going to do this now? What's that, like negative 11, something like that? Negative 11x minus 30. And then that's it. All right. Questions on this? Anybody? All right. Use one method. Use your distributive method. You know what? I got 2 minutes. I'll do the vertical method. Y'all got lucky. All right. I thought I was out of time. All right. Let's do the vertical method. So I got 6x plus 5. And then I have 5x minus 6. I'm going to multiply these. All right. Damn. All right. Negative 6 times 5. What's that? Oh, I know y'all tired. It's negative 30, right? All right. Negative 6 times 6x. That's going to give me a negative 36x, right? Imaginary 0. 5x times 5. This is plus 25x. And then 5x times 6x. This is going to give me a plus 30x squared. Then we want to add these up, right? Add straight down. Negative 30 plus 0, negative 30. Negative 36x plus 25x. What's that? Like 1, 1. That's like negative 11x, something like that. And then just bring down the 30x squared. And that's it. That's how you use your vertical method. All right, let's compare. Let's compare. Same answer? Oh, shoot. Same answer. There we go. All right. That's it for class. Any questions on this? Anybody? No? All right, come sign attendance. May I take this down? I need time to download it. That's why I'm asking. Just let me know. Let me know when I could take it down, please. We need time to download. Time to download. Woo. Fresh off the press. There you go. Yeah. Mm-hmm. Thank you. You're welcome. Anytime. Can I take this down, everybody? It's cool. All right. Appreciate y'all.